Hi everyone, let's solve the second question from today's weekly contest, that is count the number of pair pairs. So in this question we are given a zero index integer array nums of size n, and we have two integers lower and upper, right? And we have to return the number of pair pairs. So a pair I comma j is fair if I is less than j and j is less than n, and whatever be the value at these positions, if we add them, it should be greater than this lower value and less than this upper value, right? So let's see. So what do we have to do? We have to consider the pairs that we can form. So let's see with 0 what pairs we can form. So with 0 we can form 0 comma 1, 0 comma 7, 0 comma 4, 0 comma 4 and 0 comma 5, right? Then then with 1 we will consider we can form 1 comma 7, 1 comma 4, 1 comma 4, 1 comma 5, right? Now you might ask, why are we not considering 1 comma 0 a pair? Because in the question it is given that I should be less than j, so 0 comma 1 is a valid pair, right? 1 comma 0 will not be, so that is why we are considering it only this way. We can't consider 1 comma 0 a pair. Then we will form with 7, right? With 7 we will have 7 comma 4 twice and 7 comma 5, right? And after this we will have 4 comma 4 and 4 comma 5, right? With 5 we don't have any value further, so we will not form any pairs with 5 as the first element. Now we will check out of all these pairs what are the fair pairs. So fair pairs will be the pairs with the sum lying in this range, right? Which is 3 comma 6, 3 and 6 inclusive. So if we check, let me take a different pen. So if we check, this is not a valid pair, this is also not a valid pair, but these three, if you see, their sum is 4, 4 and 5. They lie in this range, right? So we will consider these three pairs as fair, right? Then again, this is not a fair pair, but if you see these three pairs, they are also pair. So again 3, right? Then you will see these pairs, right? They're again out of bounds of this range. Then also these pairs, they are also out of bound of this range. So out of all the valid pairs, we have 3 plus 3, that is 6 total pairs that are fair, right? So now, so I hope you have understood what the question is. Now let's see how we'll be solving it. Okay. So if you try to solve it using the traditional way that you take two for loops and then you traverse into this nums array and you find all the pairs, right? And then you check whether those pairs lie in this range or not, then that will take O of n square. So we will not we will be getting TLE in this case, right? Because the array size given in the question is huge, right? It is 10 raised power 5. So let's see what else we can do. So if I say, if I sort this, right? If I sort this array, okay, if I sort this, what will I get? We will get 0, 1 and 4 and 4 and 5 and 7. Now you might ask that if we will sort this, then this condition will become false, because then we will be considering 4 comma 7 a pair, right? And 4 comma 7 is not a pair, 7 comma 4 is a valid pair. Now with this condition, what we are actually doing is we are limiting the pairs, because with any two values at hand, right? If we have 0, 1, so the valid pairs are 0, 1 and 1 comma 0, right? We can form these two pairs, but with this we are limiting our pair to 0 comma 1, right? So we are considering this not a valid pair, but what we have to consider in the question is just the sum that we get out of this pair, right? So we really don't care whether this 1 comes before 0, the sum remains the same, right, of this pair. So even if we even if we take it this way, so the pair that we will be considering is 4, 7, right? But actually its value is 11, and also 7 comma 4, which is a valid pair according to this question, also has 11, right, sum. So right, so I hope you have understood why we can sort this, right? So after sorting this question becomes very easy, right? So now we can simply apply the concept of upper bound and lower bound, right? So what we will do, we will take this particular index and then we will be calculating the lower bound, that is the value that the greatest value that gives us a sum greater than equal to this lower value, and we will find the upper bound of this. with this particular, with a particular index element, right? And then we will simply do what? We will take, so we will simply take those indexes as let's say low for the lower bound index and high for the upper bound index. And if we simply add their difference, those all the pairs that lie in this particular range will be the valid pairs, right? So let's see. So what we will do, our I is currently here, right? We will be traversing inside of this array, and then what we will be doing is we will be calculating the lower bound and the upper bound each time for every index, right? So from 7 if we start, so we have this 0, and currently our low variable will be at the right position, that is the last position of this array. Then what we will do, we will keep checking that nums of I plus nums of low, this particular value, if it is greater than equal to this lower value, right? So we will find the lower bound. So we will keep decrementing it, right, for all the elements until where we can find this condition to be true. So if we see this condition, it is true up to this index, because at this index it will become false, right? So our low will be pointing here. Now then we will calculate our upper bound, so which will be num of I, right, and num of high, let's say, right, it should be greater than this upper value, right? So if we will calculate it, our high will only be here, because here it will become false, right? Because 5 is less than 6, 5 plus 0, right? So here we have 5, so our high will be pointing here. So if you see all the pairs that you form in this particular range, right, they are our valid pairs. So we have to simply do what? We have to do high minus low. So what is this index that low is pointing to? It is 2, right? And what is this index that is high pointing to? It is 0, 1, 2, 3, 4, 5, 5, right? So if you add high minus low, right, you will get 3 pairs, which we saw, right? The valid pairs are what? 0, 1, 0, 4, and 0, 4 and 0, 5, right? These are our, 0, 1 is not a valid pair, sorry, right? So we have these 3 valid pairs, right? All these pairs that we have got are valid pairs, and we have to add it inside of our count. Similarly, we will do it for the next element. We will be calculating the upper bound and the lower bound, and we will keep adding the difference, right, between the high and the low pointers, right? So this is what we have to do, and this will be taking O of n log n complexity, right? For sorting the array also, O of n log n, right? And for let's first see the code also. Okay, so what we are doing is, first we are just sorting this, right? And then we have this count variable, and then we have these 3 variables, right? That is I and low and high, right? So initially low and high will be pointing to the last index of the array, right? And then we will have this while loop. In this while loop, what we are doing is we are taking these lower bound and we are taking the high upper bound, right? And then wherever these pointers are pointing at, right, we will simply add it to our count variable, and then we will move on to the next index. So this will be O of n basically, and for sorting we will have O of n log n. So overall complexity becomes O of n log n. So in the end we will return count.